Hi, I'm Dr. Mitch Medina. Those of you who are watching us on YouTube, you have right here on my channel, Dr. Mitch TV, other programs in which we've talked about the amazing results that we've experienced with our patented herbal remedy for HIV/AIDS. Those of you in our audience who live in Kenya, which is where the herbs are from, you have had an opportunity to see on broadcast TV some of the amazing, amazing stories that God has given us through this formula, which has helped everybody who has taken it, which has caused 17 people to go from positive to negative, which has produced 4 absolute cures from HIV/AIDS. These things have never happened with ARVs or any other known therapy for HIV/AIDS. And it's a tremendous hope that is now on the horizon for the tens of millions of people worldwide who are living with HIV/AIDS. Now, in our broadcast TV, we really can't go into the technical aspects of what our therapy is doing because they're just too sophisticated technically for a general audience. But quite a number of people have requested to know more about the down and dirty mechanics of how this remedy actually works in the human body. Now, we are still studying this, and we don't know absolutely every detail. But I'm sitting here with the primary inventor of the herbal remedy, Dr. Paul Chepkwony, I should say Professor Paul Chepkwony. Paul is my very good friend, and we have been working together on this project for the last 6 years. He is the one who has the greatest degree of the 3 co-inventors of technical competence in the chemistry of the remedy. My wife, Dr. Maria Medina, she is the one who actually has the most clinical know-how of the 3 of us. But Maria really doesn't like to be on camera. She just doesn't like to be on TV. So although she's around, she's not going to be in this program. But Paul and I are going to just have a little bit of a chat about this remedy and the therapy, how it came to be developed, and how it came to be applied. I am also a co-inventor of this remedy, and I have been in the background in this project from the beginning, and I've contributed my little suggestions here and there. My PhD, I've identified myself as Dr. Mitch Medina. My PhD is in theology. Now somebody might say, what in the world does a preacher know about HIV/AIDS? Well, one thing I can tell you is that as a preacher, I'm concerned about my personal integrity. I can also tell you that my PhD in theology is just one of 6 university degrees that I hold, and that I am also an inventor, and I have 26, going soon on 27 U.S. patents. 24 are not in this field, they are in other fields. One of my degrees is in computer science, and I have over a dozen patents in the area of computers. I don't want to take too much time on this, but some of you are conditioned by mass media presentations, and especially American culture, American TV and movies, to assume that anybody who believes the Bible and who follows Jesus Christ must be a moron. With all due respect, I am not a moron. I'm an educated person. I'm not going to sit here and talk nonsense about what my IQ is, though I know it. But as an inventor and a preacher who's concerned about integrity, a highly educated person, and one who understands, because I've been taught by Paul and by my wife, Dr. Maria, a lot of the chemical and clinical aspects of this invention, I also am qualified to speak on this subject. So please forget about the last movie you saw where the preacher was a con artist and was stealing the money out of the plate and whatever else. That's somebody else's movie. That's not Dr. Mitch Medina's movie. So with those little formalities put aside, having gone through them, we want to ask God to bless you, and we welcome you into this little chat, heart-to-heart talk that I'm going to have with my dear friend and co-inventor, Professor Dr. Paul Chepkwony. And before Paul, I turn it over to you and let you introduce yourself. I also want to say to anybody out there who may have a misconception that because we are speaking to you from the nation of Kenya in the continent of Africa, that we are witch doctors, or that when we're not on TV, we run around in grass skirts and we're cannibals and we eat people, and whatever other cultural misconceptions you may have about that. I also ask you to put those out of your mind. Here in Africa, we have phenomenally intelligent people, well-educated, who are the scientific peers of anybody in the world. And one of them is my good friend, Professor Paul Chepkwony. Now, Paul, why don't you go ahead and introduce yourself? I'm just going to take a little drink of water because I got a frog in my throat. God bless you.
Thank you, Mitch, for the elaborate introduction. I would like to let our viewers today to know that I'm Professor Paul Chepkwony, as mentioned by Dr. Mitch. I am a professor of a branch of chemistry called organic chemistry, but the specialized area of it called natural products, or by another name, natural pharmaceutical chemistry. I trained at PhD level at the Jomo Kenyatta University of Agriculture and Technology, but right now I'm a professor at the Chepkwony University or University College, which is under Moi University. I did my master's at the University of Nairobi in the same field of chemistry. My first degree is in chemistry. I'm a chemistry major from the Jomo Kenyatta University of Agriculture and Technology as well. And I've had other international trainings, one of which is in traditional Chinese medicine, which I acquired from Tianjin University of Traditional Chinese Medicine in China. Apparently, I'm also a systems administrator, which I was trained in Germany, Darmstadt, by a company called Varian. It manufactures spectrophotometers. And that is where I was also trained as a nuclear magnetic resonance operator, NMR if you wish. And NMR is a machine that is used to determine structures of compounds, like the ones we'll be talking about later, that have been reported from the plants that are useful in the recipe that we'll be talking to our viewers about. And I've taught at the university and done research as well for 16 years. But as a chemist, I have been in the field studying chemistry for about 22 years.
Well, it's an honor for this preacher to be seated next to you. Now, Paul, let's start from the beginning. This remedy that we're using for HIV/AIDS, we've already told the story of how you came to discover it, which was that you had a cousin who was sick. You had been doing background researches in potential medicinal properties of ceremonial plants of your ethnic community, the Kipsigis community or sub-community of the Kalenjin here in Kenya in the Rift Valley province. Now, so because under the impetus, the motivation of your sister being sick, cousin being sick, you decided to use some of these plants that you had been assaying. You assayed over 50 plants, and you found that most of them were not really useful, but you found that there were 14 that were in fact useful. You combined them in a remedy, in a recipe, which you administered to your cousin, and then your cousin got better. And since then, we've applied that therapy to more than 200 people, and every single one of them has gotten better. Not everyone has been cured. We have had 17 transitions from positive to negative. We have had 4 absolute cures. We don't overclaim about this remedy. We tell it like it is. Now, but as we return to the recipe and how it came to be formulated, can you recite from memory, do you happen to recall the names of all of the plants that you used?
Do you mean the scientific names or Kipsigis names?
why don't you start off with the scientific names, if you remember them, and the Kipsigis names too. We can make it multicultural.
Well, Mitch, I know all the plants, and I'm glad you said we are your teachers, I and Maria. And I'm tempted to give you an exam.
Oh, gosh.
So I know whether you remember.
Okay, Prof.
Since we patented the recipe, all the names too are appearing.
Yes, and
on the patent.
And as the one of our team who is an expert in patents, I can tell our audience that the U.S. patent number is U.S. patent number 7556830. 7,556,830. And you can go and Google it, you can find it, and you can read it, and you can verify the things that we're telling you.
But if you would like to know whether I know them by their Kipsigis names, yes, I do. But since I have not taught you any Kipsigis, it may be relevant to you.
Well, no, I'd like to hear the names in Kipsigis. I think if you want to give me an exam on the Latin names, maybe I can pass, or at least I can probably name most of them without looking. But the Kipsigis names I've never heard, so it would be interesting to hear that.
Wow, that is very interesting. I'll just give you a few names.
Okay.
One, Synandate. Can you repeat what I've said?
I'll try. Synandate.
Synandate is one of them.
Synandate, okay.
Tendwet.
Tendwet
is one of them. Ararwet is one of them.
Ararwet. Did I say it right? Ararwet?
Yes.
Okay.
The one I'm going to mention is very hard.
Oh, okay.
Cheptarurwaget.
Cheptarurwaget.
Yes. I think I can teach you 4 names for today. And another 4 names next time and another time.
Now,
until we are done.
Okay. Now, which one is Dovialis abyssinica?
You want to know?
In Kipsigis. Because Dovialis abyssinica and Clutia robusta, these are the 2 most powerful plants in our recipe. Mm-hmm. So I'm curious to know, Dovialis abyssinica and Clutia robusta, what are the Kipsigis names?
I'll tell you in a minute.
Oh, okay.
Yes.
Okay.
Yeah, yes.
Okay.
Good.
Because I know the Latin taxonomical names because we had to look them up to get the patent. We had to get a botanist to help us with that because you knew the plants, but we didn't necessarily know until we got help. We didn't necessarily know what the Latin taxonomical names were.
And I think just to make it very easy even for you, Mitch, what I'll do is give you the taxonomic names and the Kipsigis equivalent.
Oh, okay.
So it's easier even for our viewers that we can post these names. Though, of course, I know there may not be as many Kipsigis in the world.
Yes, there aren't so many. But so before now, my Kipsigis was limited to the word chamge, which you also taught me, which means hello. So now I'm already learning more. Now I know 5 words, if I remember the other 4. So you put together these 14 plants in a recipe, and then you gave it to your cousin. Now, some people have raised concerns about potential toxicity of this remedy. And we discussed that in one of our broadcast programs, but maybe you'd care to address it now here when we have a little more time to just stretch back and talk freely.
Yes, that's a very important concern, Mitch, and viewers as well as the users have a right to know aspects about especially safety. As someone who is trained in the field, I am very aware of the requirements on any drug that is new and coming into the market, that one requirement is its level of efficacy, and safety is paramount. These are aspects that I put into consideration when I was formulating the recipe from 14 plants. And I would like to add that when I went to China, where I trained in advanced traditional Chinese medicine, there is something called 7 consequences that are possible when you mix plants, whatever number. And these 7 consequences, as far as traditional Chinese medicine is concerned, is very important for drug design. I'll give you a few possibilities that I took into account during the formulation. One of them is that there's a possibility that if you mix 1 or 2 plants, 2 or more plants together, you could easily enhance the efficacy of each. There's a possibility too that one plant can be the major one and another one is a subsidiary, and mixing the two could lead to a situation where the subsidiary plant enhances the efficacy of the major one. There are cases where you have 2 plants which are active individually, but when you mix them, they become useless. And there are situations where you mix 2 very efficacious plants individually, and they become poisonous. Very interesting. But there is also another very interesting scenario where you have a plant which has efficacious properties, but within it are poisons. And that if you bring in 2 or more plants, the poisons or the toxins can be neutralized, and the efficacious aspect, which is important for healing, is retained. So we have those permutations, and in total there are 7, and we call them the 7 consequences. And these are the aspects that were factored during the formulation of the 14 plants into the recipe. And I can tell you confidently that during the mixing, the beginning point was which of these 14 plants are key, and there are 2 of them. When you've just said the Vialis abyssinica, if I can give you an example of this plant. You remember the number 2?
Yes, Clutia robusta.
Clutia robusta. Then the 12 are subsidiary, without which the 2 wouldn't exhibit maximum efficacy. So the mixing has been done in such a way that any additional plant to the 2 would enhance the efficacy of each of the 2 to maximum levels.
Yes, and of those 12, let me see, I remember, I don't have the patent in front of me, but I remember there's Prunella vulgaris, Bersama abyssinica, let me see.
All of them, and since you've given the viewers a patent, I'm sure they'll be very
that they can look them up, yes.
Yes, those scientific names really also very confusing to the general
yes,
public.
Yes.
But I think for the purposes of this show, it's just important for them to know that these are 14 plants.
Yes.
And they've been mixed in a manner that the inventor, who happens to be myself, took into account that there was need to eliminate any possible toxicities during the mixing process. And as you can see, this is a high-level training. It's not just anybody who can do it. It's got to be somebody who is thoroughly trained in aspects of alternative medicine.
Now, picking up on this high-level training, you actually formulated this recipe empirically and found out empirically that it works. And that's actually the course of discovery of most medicines. For example, aspirin is derived from the bark of a tree, and it was used as an analgesic, and eventually it was analyzed, and it was found to be acetylsalicylic acid, and now everybody can go and buy aspirin. But originally it came from the bark of a tree. Penicillin was something that was discovered empirically. Somebody made a mistake, and they left a petri dish uncovered. In the petri dish, there was a culture of bacteria growing. I don't quite remember whether it was staph bacteria, which was the culture that you used in assaying the plants originally. You used Staphylococcus aureus. I do not recall in the case of penicillin whether the culture in the petri dish was Staphylococcus bacteria as well. I think they may have been Streptococcus. Anyway, there was a Streptococcus, this bacterial culture was growing in a petri dish, and somebody had put a little bit of bread in the petri dish, another mistake. Then they left the thing uncovered, and bread mold started growing on this uncovered dish. I mean, this was from an experimental point of view, it was a complete screw up. But when they came back and they saw the zone of inhibition, which we mentioned in the patent, that around there was this culture, excuse me, I'm messing up the penicillin story, and since this is a free discussion, let me correct it. There was a culture of bacteria growing in a nutrient medium. It was not on bread. This is a mistake. I'm remembering the story better now. And it got contaminated with bread mold. The nutrient medium, which was just not bread, but it got contaminated with bread mold. And then somebody looked at it, and they noticed that in the nutrient medium around the green bread mold, there was a zone of inhibition where the bacteria weren't replicating. So it was sort of like a bullseye, that in the middle there was this little bit of mold, and then there was a whole larger area around the bit of mold where there were no bacteria, and then further away the bacteria culture was thriving again. So somebody said, what in the world is this that is inhibiting the growth of these bacteria? So they analyzed it, and they discovered that this bread mold, which is what it was when they looked at it, actually contained the drug penicillin, which was the foundation of all modern antibiotics. So it wasn't like somebody set off to go and synthesize penicillin. It was much later when it was synthesized. It was empirically discovered to be effective. Similarly, the drug quinine, which was the first treatment for malaria that anybody ever knew about it. Now we have other drugs for malaria. But the drug quinine came about as a result of Native American traditional medicine lore, where Native Americans, that is American Indians, had empirically discovered that by chewing the bark of the cinchona tree, malaria could be kept at bay. Eventually, the cinchona tree was analyzed, and it was found that it contained quinine. And quinine then became the first known treatment for malaria. It was actually discovered in Latin America, in the New World, but then when white colonizers came to Africa, where the same disease existed, they already knew about the use of quinine, and in fact they taught it to the local Africans who had no remedy for malaria. I guess what I'm trying to say, perhaps I've been a little too discursive, is that many drugs have been empirically derived from natural herbs without anybody necessarily knowing what they were doing when they started. This is perhaps one of the reasons why the accumulated wisdom of mankind in the traditional medicines of various cultures is so important.
True, and just to beef up your explanation, Mitch, it is true that quite a number of effective medicines are from plants. And I would like to give the example of the most powerful anti-malarial drug at the moment from China. It's called artemisinin. It is from a plant called Artemisia annua. And
the drug is marketed under the name Coartem.
It is marketed under the name Coartem.
Yes, yes.
Going back to your penicillin story and zones of inhibition, this is exactly what I did when I was working on the individual plants from 1997, getting Staphylococcus aureus, growing them and then applying and determining the zones of inhibition. I also used E. coli, which is a very, very deadly pathogen lately, especially when with the advent of HIV/AIDS.
What does the E stand for, by the way?
Escherichia coli.
Escherichia coli.
Escherichia coli.
Escherichia coli. And, right. Okay.
Basically, in the initial screening, I wanted to know which then would cause the greatest zone of inhibition. And that formed the basis for elimination from 50 to 40, among other methods that were used. And looking at alternative medicine, generally, it isn't just plants, even animals and animal parts are used, as well as soils and rocks.
Some of that is quackery, though, like the Chinese believing that rhino horns can make them sexually potent.
Of course, yes, true. But I know that there are certain parts of certain animals, like animal fat from fish, even reptiles, are very strong steroids.
No, I didn't know that.
A fat from a chicken, a cock especially, is normally squeezed into an infected ear which is oozing pus, and it recovers.
Yes.
So we have plants and animals being used as medicine for a long time.
When I was growing up in the United States, there was this horrible medicine that nobody wanted to take called cod liver oil that was good for all kinds of intestinal problems, except it tasted horrible, so nobody wanted to take it.
Every Kenyan, I'm sure, took cod liver oil when he was a baby. And this is an example of a medicine coming from
a fish.
A fish.
The codfish.
And just back to the issue of the 14 plants that
yes,
the plants are ceremonial amongst the Kipsigis tribe, as you introduced. So the screening had to be done because I was so curious to know what is it that each of them would have, especially the possibility that after screening, the plants could be used to treat opportunistic infection in individuals with HIV/AIDS. And the thinking behind it is that most of the Western drugs were becoming so expensive, not available, and that motivated me, as well as the fact that a close relative got sick.
Now, I just want to interject here for a moment. Now, I mentioned quackery in connection with rhino horn. Now, of course, you, as a professor in chemistry, you weren't dealing in quackery. I mean, the Chinese think that rhino horn will make them sexually potent because it looks like a phallus, but there's no objective evidence to support that claim. This is just a wild superstition which they have, which is very unfortunate for the rhinos because they're being decimated for nothing to get their horns. But when you did the research, you took extracts of the plants and you put them in cultures of both Staphylococcus aureus and also E-period coli. I'm not sure if I can get that name right.
Escherichia
coli. And you noted the exact same zone of inhibition around the extract in the bacterial culture as had originally led to the discovery of penicillin, which came through the observation of a zone of inhibition around a bit of mold in a bacterial culture.
True.
So you weren't dealing in quackery or witch doctory or anything of that nature. You were working as a research scientist studying the properties of plants. I, for my part, just want to underscore this distinction because people in the audience may have all kinds of strange ideas that when you say traditional Kipsigis ceremonial plants, you're talking about wild things, but we're not. I mean, of course, they're wild plants, but I mean crazy things. But they're not. You are a PhD chemist and a professor, and you were going about doing scientific research into isolation of potential medicinal qualities in these ceremonial plants. And in the course of your research, you assayed more than 50 plants and discarded over 36 of them as worthless. However, you found 14 that did, in fact, have medicinal antibiotic properties in cultures of Staphylococcus aureus and E. coli. I'm not going to try to say this.
Yes, just to cut the story short, Mitch, the thing that by training I should understand is that any research in the field of medicine must conform with the best practices. That even during preliminary trials, everything must fit within best practices. Second, having known the most probable plants to put aside and which ones to continue with, the next level was laboratory. To extract them in small quantities, to know how many components are there, using technology in chemistry called chromatography. And then, of course, going after the chemicals that are seen and extracting them and purifying them into components that ultimately will be analyzed and structure determined. And this aspect that is covered under laboratory is what scientists in my field would call good laboratory practices.
Now, you know, we're sort of on the inside in this. We're in the know, which our audience is not. We know that we ultimately. Here, let me back up a little bit. There are basically. Maybe you should explain this rather than me. Why don't you explain to our audience what is a phytoalexin and what its function is? in plant biology and what the types of phytoalexins are?
Well, the word phyto is from plants, and the phytoalexins are secondary metabolites from plants whose proper description I would like to give, but through a chemical structure which I can't display. However, these are plant substances that are known to have efficacy which would target bacteria and fungi as well.
Now, the plant itself produces phytoalexins to defend itself against this kind of attack, against bacterial and fungal attack. Isn't that correct?
That's correct.
And the phytoalexins themselves vary from plant to plant and even from environment to environment, depending on the nature of the environmental threats that exist in a given habitat to a given plant.
You're correct. The broader term that is usually used is secondary metabolites.
Mm-hmm.
And it is true that plants do produce secondary metabolites for self-defense. When the plant is producing it, it usually doesn't have the intentions of producing a medicine for humans.
Right.
It's for their own survival. But incidentally, some of them, by luck, are useful for treatment of various diseases. And I can confirm to you from the statement you've made that secondary metabolites produced by the same species of a plant will vary from altitude to altitude, from soil to soil. There are soils that could be acidic, others are basic. So the same plant growing under different soil conditions would produce different secondary metabolites. But there will always be a few specialized secondary metabolites that will always be produced irrespective of where. But the others that assist it will depend really on where the plant is growing. So you are right.
So after you had created empirically this recipe, the formula that we're now using to treat people who are living with HIV/AIDS, then after that you embarked on an inquiry into the nature of the phytoalexins that might possibly be present in that recipe, which empirically worked.
True.
And I wonder if, well, I think I can supply this information because I know it. There are basically three classes of phytoalexins. There are alkaloids, and we've already discussed how the U.S. Patent Office has granted just recently a patent on the alkaloid components of your recipe, of which you isolated 46. Then, in addition, another class of phytoalexins are called terpenoids, and you isolated 20 of those, and we have patent pending on that. It hasn't been allowed yet, but it's reasonable to expect that it will because it's a novel combination. And then a third class is glycosteroids or steroid glycosides, of which there are 26, and on that we also have a patent pending. But it takes years to get a patent sometimes, and the patent office takes its sweet time about examining it. We know what the stuff is, and we know that it's a novel combination of ingredients that has never been made by man before, and therefore it is patentable subject matter under 35 U.S.C. 101. But what I would like you to fill us in about is the nature of the chemistry that you did, and I'd like you to go into real deep scientific detail on this, to identify the specific phytoalexins in the three classes, which you did from the empirical formulation. How did you go about that work?
This is a very important question. But just to take viewers through the standard procedure by someone in my field, if you have a plant that you think has got something and you would like to go all the way and know the name and structure of that active ingredient, the first step would be, of course, to collect the plant material. And then it's supposed to be chopped into pieces, ground into fine powder, and extraction is done. The choice of a solvent you use depends on the nature of secondary metabolites of interest. In the case of alkaloids, we do acid extraction, because the moment you acidify the water used to extract the ground material, the alkaloids then dissolve in the acidified water. That is the only way to get them out, because alkaloids exist as solids within the fabric of the ground material. So when you acidify, you get them out, and then later on you basify, add ammonia solution, and then you precipitate everything, and you have your alkaloids. If they are not that pure, you use a process of chromatography or chromatographic separation to completely resolve each of the alkaloids into individual components.
Yeah, could you tell me a little bit about chromatographic separation?
Now, what happens is we have a material, say a glass plate or aluminum plate, which is coated with a stationary phase. In most cases, the stationary phase could be silica. And then usually when it's applied on the surface of the stationary phase, different components move at different speeds, so that after some time they get resolved into pure components and you get them out.
Sort of by gravity, or is that how that works?
No, it is by affinity. There are those that stick onto the surface of the stationary phase, so they are retained longer. Those that do not stick as much are carried along by the solvent which you use.
Oh, I understand. So you're washing, in essence, you're washing this plate with solvent.
Through the stationary phase.
I understand. And then you're filtering the solution, or you're collecting the solution.
Then you collect the solution, and the solution will contain different fractions, which then will ultimately be repurified to give you pure components.
And how do you purify them?
There are methods. One can just be crystallization. The different components can crystallize depending on the amounts. One other way would be to run it through another plate. So you resolve it a second time.
I see.
Until you ultimately have components as individual components. The moment you have these pure components, then you submit them for structure determination using various methods. There are two key methods that I use.
Yes, this is very interesting because to me, because in fact I even want to learn about this, because I know that we did together this sort of, it seems like magic of chemical structure determination. I'd like you to explain the details of how that's done, and in which I happen to know, because we've been friends for a long time, I know that you're a world-class expert in that particular field.
True, and we have spectrophotometric we have spectroscopic methods. These are methods that use machines that are called spectrophotometers, and one of them is called mass spectrophotometer. This determines the molecular weight. So when I know the molecular weight of a compound, I can guess what most probably it is. Whatever it is, I can guess from the molecular weight, because I can compare with standard molecular weights that are already available. But this needs to be looked at together with information from a machine, which I called earlier nuclear magnetic resonance machine, NMR. It's also a spectrophotometer. It shows you how the carbon atoms are joined together, how the hydrogen atoms are joined to carbon, and how generally the skeleton of the molecule is formed.
So the first machine, which is the
mass spectrometer, if you wish.
Mass spectrometer. That tells you the molecular weight of the compound. Now you're saying that from the molecular weight of the compound, you can sort of guess what it might be. However, once you add to it the data from the nuclear magnetoresonance machine.
NMR machine.
NMR. Yeah, I mean, I know what these things are, but I'm just not used to, I don't throw these words around in ordinary.
So
nuclear magnetoresonance. With that data, then you can refine the guess that you have from the mass spectrometer into a concrete drawing and identification of the structure of the actual purified compound, which you've previously arrived at through this solvent washing on the plate.
True, and just to add a little bit more.
Please, you're the professor.
NMR. The NMR shows connectivity. Most of these secondary metabolites are majorly carbon, hydrogen, oxygen, and nitrogen. So the NMR machine will show you how they are connected and how many they are in number, so that when you add up the atomic masses of individual atoms, they will more or less equal the molecular mass given by the MS. So this is roughly how it's done. But within NMR, there's so many experiments that are done. It's not just one, there are many. All these are put together to give you a general picture and a complete picture as well later about the kind of compound that you're dealing with. And where a compound is already known, you can confirm through its melting point. If you have a compound with a melting point, say 50 degrees centigrade, if then you have this extract also melting at 50 degrees centigrade, so most probably that's it.
You have correctly identified it. It's a check on your work.
The scientific community has developed and made research very easy, because we have libraries of compounds which you can easily compare with. The moment you submit this, you are able to quickly fix the structure if it's already existing in the library, because the computer can compare for you.
And then you come up with these wonderful names, which I've had to transcribe in connection with our patent applications. 1-alpha beta cofferol X morphous. I don't know, I'm just making something up.
Those are standard IUPAC names.
IUPAC, what's that?
International Union of Pure and Applied Chemistry.
Oh, okay.
Conventional names, so that if you're in Africa, the same name you give must be understood by someone in New York.
The name is derived from the structure, correct?
From the structure. So there's a conventional way of naming compounds, whether new or known.
My wife told me that in medical school, part of her training, the exams that they used to give, was that they would either give you a molecular diagram. Here, this is, for example, I don't know if we can zoom in on it. This is not one of the phytoalexins in our remedy. This is a molecular diagram of something else. It doesn't matter what it is. And so they would give you, or give her, I should be precise. I never went through this training myself. But they would give you the molecular diagram of something. And as your exam question, you would have to
give a name.
Give the name.
Correct.
Or alternatively, they would give you the name and you would have to derive the molecular diagram. And that was your exam question.
True.
And this is what chemists do.
And it's a standard procedure in any chemistry class, beginning from high school. Someone needs to understand the system of naming. We call it nomenclature. And if you do not understand basic nomenclature as a chemist, then you are not a chemist. At my level, at the level of top-notch scientists in the world, there's a possibility they can isolate something new. And they should apply the standard procedure when giving a name to a newly isolated compound.
Now, in connection with your work of isolating the 86 phytoalexins from the 14 plants, did you in fact encounter any novel compounds, or were you able to simply verify from reference libraries which one was which?
All the compounds that were isolated are known. There was no new compound, and I think that was so easy for us.
Easy for you.
But even if it were new, that wouldn't have been a problem, because again, there's a verification process, which then would require that you do X-ray and everything else to confirm that there is no X-ray picture which is similar to the X-ray of the compound that you are claiming to be new. And you can also beef up that with very advanced searches to confirm that what you have really is new, so that you don't report something as new and the next day.
That turns out that somebody found it already.
Yes.
Now I remember that you told me, because I asked you, once you had the structures, you had developed the structures and the chemical names. I had raised the question, do you see any cyanide groups in here? And so, were you able to check that?
Yes, it's a very basic science, by the way, to determine what. When you talk about a cyanide functional group.
The cyanides are poisons, by the way.
Poisonous, by the way.
Yeah.
The thing that I need to add to this is, apart from the two spectroscopic methods used.
Yes.
In addition, infrared spectroscopy, IR, would just be used to determine the general functional groups.
Yes.
As just a quick way of knowing whether you have something like that. It shows you that there's a machine called IR, which does it very quickly. And even if someone didn't have IR, that information would easily be obtained from NMR. And again, having fixed the structure, because ultimately the final structure should show that it has cyanide group or it doesn't. In our case, there was no cyanide functional group.
And so you were able to go through these structures and look for various, cyanide isn't the only potentially toxic functional group. There are others, and you checked through all of these structures to make sure that there were no toxic or potentially toxic functional groups.
True.
Could you give me the names, because the only one that I know is cyanide. Could you give me the names of some other potentially toxic cyanide groups, functional groups?
Well, Maybe not functional groups. We can say other possible toxic chemical substances,
Yes.
or metals, if you wish. We have heavy metals as well.
Heavy metals, but potentially...
Which could find their way into the recipe.
Of which I would know, for example, that mercury is one, and is toxic. Lead, yes. Yeah.
And we have a machine which does that very well, analyzes for the presence of metals and heavy metals as well.
So with our stuff, did you do that heavy metal testing?
I did that, and there is no heavy metal whatsoever in the recipe.
Now I'm really probing here, but I want people to be absolutely assured of the safety of this remedy. Heavy metals aren't organic compounds. I know that cyanide is, in fact, an organic compound. Are there other organic functional groups or compounds or possible components of the phytoalexins that could possibly be toxic, and were you able to check for them?
Yes, we have other classes of alkaloids, by the way, that are very poisonous. And if you remember, there was a man called Socrates.
Yes.
Who was given an
hemlock.
Hemlock. Hemlock is very, very poisonous class of alkaloids, which when taken would kill within the same length as a lethal injection would do. And therefore, I was very keen to know, first and foremost, the classes of alkaloids we're dealing with. Because there are those that are very poisonous. The other alkaloids are those that are found on pepper. Pepper,
the spice, pepper.
Yeah, they are not as poisonous, but of course the bitterness alone cannot allow anyone to use this toughest medicine, although people of course use it to spice up food.
So you're saying there are actually toxins in black pepper which we use on food?
No, they are not toxins.
Oh, okay.
But basically,
but they're alkaloids.
Irritation. By the one of the ways of knowing whether something is an alkaloid is the bitterness.
Oh,
but there are different types of bitternesses which you can easily classify with your tongue. The bitterness from pepper is different from the bitterness of the herbal recipe which you've been testing every morning, and the other sets of bitternesses. So all I'm saying is that the classes of alkaloids that otherwise would be poisonous being found within the recipe is a possibility that was ruled out in the process of extraction.
So in your professional competence as someone with 22 years experience in chemistry and a PhD and a university professor, you analyzed this empirical formula very, very carefully, and you were totally satisfied that there were no toxins or toxic substances, which again has been confirmed by our empirical administration of the recipe, because nobody got sick from it. It makes people better, not sick. So the empirical clinical administration is confirming the, I shouldn't say theoretical, but abstract chemical work that you did.
True, that I can confirm to you.
Yeah, well, I think it's important because people have a right to ask the appropriate safety questions about anything that it's proposed that they're supposed to ingest as a medicine or a remedy that's supposed to make them better. They have a legitimate right to ask, is it going to make me sick?
And just before I forget, you did ask me a question about the name of a plant, Clutia
robusta, yes.
Robusta, and the Kipsigis name is Kurbanyat. Can you say that?
Kurbanyat.
Yes, correct. That is the name of the one of the two
key plants, yes.
Yes. And it's a wonderful plant.
Well, God has put in it divine healing properties. In the context, in the other context that I have my other hat as a preacher and a Christian broadcaster, I keep on emphasizing the words of the scripture in Revelation 22:2. The leaves of the tree are for the healing of the nations. And so God has contrived to put in these plants phytoalexins, which the plants are creating for their own defense, but this is all part of God's wonderful creation. That the plants create these chemical substances for their own defense against environmental threats such as bacteria and fungi.
And even insects, by the way.
Oh,
insect pests.
Oh, yeah.
From invading and eating up the plants. And one thing that...
Oh, we use one of those very commonly in Kenya, pyrethrum.
Yes, to kill mosquitoes.
Which is derived from the pyrethrum, is it called pyrethrum flower? I think so.
Pyrethrum flower,
yes,
produces pyrethrins.
Pyrethrius, and we use that as an insect repellent.
Now the thing that I don't know whether you forgot to mention, because it's part of the technical aspect, is that we do not dispense the recipe as roots or bark.
Yes, yes, please, yes. You should fill that in.
I would like to let the viewers know that we did implement what the scientific community would call manufacturing, good manufacturing practices.
Why don't you describe them?
Yes, I would like to do that. In the folklore sense, the traditional sense, a herbalist would use the palm of an individual to determine dosage, so that the sick person is told, okay, take a palmful of the extract for so many times a day, for so many months. And it is true that there is a relationship between the size of one's palm and the body weight. Mm. So the bigger you are, the more you scoop and the higher the dosage. Mm-hmm. The smaller you are, the little the dosage, and therefore that is how they understand safety. But as far as we are concerned, the recipe is processed just like in a pharmaceutical factory, where the plant materials having been mixed are boiled and extracted in a standard way, filtered thoroughly, and then mixed with excipients, which include, of course, starch, magnesium stearate, amongst others, and formulated in such a way that they incorporated, whenever they incorporated into capsules of known empty gelatin materials of known capacity, they are exactly like 250 milligrams or 500 milligrams. So the calculation is thoroughly done. And our patients, as you know, do take home capsules and not bags. And this is contrary to even what I saw in China. People go to the hospital in China, they prefer to be given herbs, but when they go home, they go in paper bags, carrying weight of material. So if somebody is so sick and is given 5 kilos of material, it's inconvenient for them. And then, of course, the shelf life would easily be compromised, especially having boiled and the patient didn't drink everything. So this is something that I needed to say, which you forgot.
Well, look, you're my teacher, but I have to make reference to my other teacher in respect of this, because when you originally began to administer this remedy, you were doing it in the form of a tea, which was brewed from the plant parts. But then, under the influence of my other teacher, the camera shy one, Dr. Maria Medina, we actually implemented a manufacturing standard whereby the dose could be standardized, and we now dispense the remedy in capsule form, and there's no guesswork about exactly how much active ingredient that you're getting in a given capsule, because we know we've standardized it.
True.
We've standardized it. So there's...
I remember enough, one of the shows we did show our viewers the capsule. I'm not sure.
Yes, we did. We did.
We could even pick it up now.
Oh, I wish I had a package here, and I would just wave it. I would just wave it. Actually, we have to... This has been a fascinating chat, and I think that we have covered probably most of the things that people might be interested in with respect to this remedy. Now, it so happens that you've been hearing noises in the background. I don't know if they're coming over in TV or not, but there's a phone call that's coming in for me right at this moment, and this is God. We did not arrange it to be this way. There's a phone call coming in from me from a very prominent physician in the United States who is interested in researching and studying the properties of the remedy that you primarily and my wife and I as contributors have invented and patented in the United States. So perhaps we need to say farewell to our viewers, and let's go and attend to this phone call from Dr. Feingold, and perhaps we can explain to Dr. Feingold some of the things which we've been explaining here to our viewers on YouTube. And Paul, I do want to thank you so very much for availing yourself and sharing the fruits of your vast knowledge and experience in this field with those of our viewers on YouTube who may be interested and perhaps are in a position to be able to understand some of the deeper scientific processes that we've gone through in developing this wonderful remedy for people who are living with HIV/AIDS. In our commercial broadcasts, or I shouldn't say commercial, I should say, because they're not commercial, there is no commerce involved in this. In our public broadcasts, our on-air broadcasts, we don't have the time or liberty to go into this kind of technological discussion. If we did, people would probably just turn it off, or if they kept watching, many people might not understand it. But just for the record, we wanted to give our viewers on YouTube some kind of a sense of the scientific process that primarily Professor Chepkwony and to my wife, Dr. MD Maria Medina, has also made some contributions to this invention, which we haven't discussed in this program and we may not be ready to discuss for some time. And I've made my own little contributions as well, the smallest of the three of us. And but we wanted, I'm so grateful to you as the primary inventor for having come and shared your expertise and your knowledge of the science behind this near cure for HIV/AIDS that God has given to us pursuant to the scripture, Revelation 22:2. The leaves of the tree are for the healing of the nations. And now we want to bid our viewers goodbye, and since the leaves of the tree are for the healing of the nations, let's go take this international call and see what we can.
Thank you.
Paul, God bless you, my friend.
Thank you.
God bless you.
Thank you. Thank you.
Okay. Thank you very much, and thank you, viewers, for listening to this long presentation. I hope you've been able to capture some of what we've been trying to communicate. May God richly bless you.